Hello, my name is Ian Wright. I'm a certified senior client technical specialist with the IBM Corporation, System Storage, and today we're going to be talking about the IBM Storwize V7000 in relation to the terminology that's used in virtualized storage environments. In order to fully understand how the IBM Storwize V7000 fits into a storage area network environment, it is first important to understand some of the terminology that is used in a virtualized storage environment and in a SAN. In a typical storage area network, or SAN, the hosts in the environment are connected to a disk system by way of a switch or a router running fiber channel protocol, or sometimes through IP infrastructure where iSCSI protocol is being used. The disk system has several drives within its enclosures, which are formed into RAID groups and used to create LUNs, or volumes, for the host servers to use as disks. In an environment containing the IBM Storwize V7000, the physical disk is contained in one of two ways. The first way is within the internal SAS drive enclosures, which contain either 12 or 24 disk drives, depending on the size of the drive being used. These drives are formed into RAID groups using RAID 0, 1, 5, 6, or 10. And the RAID code itself is actually based on the same code used to maintain data protection and availability within the IBM DS8000 disk systems, our enterprise class machines. The other method of accessing physical disk in an IBM Storwize V7000 environment is through virtualizing external disk. In this case, we are connecting the IBM DS8000 disk system to the IBM Storwize V7000's canisters through the SAN. This allows the LUNs configured within the IBM DS8000 to be managed by the IBM Storwize V7000. Because the disks, both internal and external, are managed by the virtualization software, they are referred to as managed disks, or more commonly, M disks. We can then take a group of M disks within or across arrays and group them together. The drives themselves and the RAID type should all be the same for the M disks in the group. In this case, we are assuming that all the drives in the enclosure contain 300 gigabyte SAS drives with a speed of 10,000 RPMs. By grouping them together, we form a storage pool. Physical layer of storage. These are the actual hard drives in the enclosures contained internally to the IBM Storwize V7000, or hosted in an external disk system that is being presented to the IBM Storwize V7000. The RAID groups within the IBM Storwize V7000, or the LUNs and volumes presented from the external disk system to the IBM Storwize V7000, are considered to be managed disks, or M disks. M disks with similar performance characteristics within the same disk system can then be used to form storage pools. The next layer is the layer of creating volumes from the IBM Storwize V7000. When we create a volume, it is virtual and not tied to any specific RAID group, but rather to the storage pool. As such, we are able to strike volumes across all the managed disks within a storage pool, allowing us to make the best possible use of all available disk space. The volumes themselves can be created using a few different methods. First, a thick provisioned volume will have the exact amount of capacity that it appears to. That is to say that if you see a 20 gigabyte volume that is thick provisioned, it has 20 gigabytes of hard capacity reserved for within its storage pool. Secondly, we can make a thin provisioned volume. These volumes appear to have more capacity than they actually have allocated. This can be a useful feature when attempting to control the amount of physical storage that needs to be purchased for the environment as it grows. If end users are requesting large amounts of storage, but routinely using far less, thin provisioning can be a useful tool to help moderate their impact on the allocated storage. It can also be set to automatically expand volumes in case end users' growth exceeds your original setting. Finally, regardless of whether a volume is provisioned as thick or thin, we can mirror the volume. When we do this, we still have a single volume that is actually using two storage pools to write its data. Should a planned or unplanned outage impact one of the storage pools, the volume will continue to be presented without impact to the application and without interruption. This can be extremely valuable to some applications with higher availability requirements, and can be combined with remote copy to an off-site location, or to replicas or snapshots created through the flash copy technology included within the IBM Storwize V7000. These technologies will be discussed further in a future video. The volumes are then presented to hosts through either iSCSI or the Fiber Channel Protocol. All of these levels, from physical through virtualization layers and host attachment, are displayed in the context of your particular environment in the Getting Started screen of the IBM Storwize V7000 interface. This concludes the overview of the basic terminology involved in a virtualized storage environment. If you want further information, you can go to the link shown on this page, or contact your IBM sales specialist or IBM business partner. Thank you very much. Further, special thanks to the Advanced Technical Skills System Storage Group, in particular Gonzalo Fuentes, Dominic Pruitt, and Bill Wiegand for making the IBM Storwize V7000 available for these videos and for other support in creating them.